Welcome to Global Geointelligence Solutions short video on the Federated Marine Spatial Data Infrastructure Phase 4 Pilot Project, Connecting Land and Sea for Global Awareness. The islands in the Caribbean lie in the path of weather events such as tropical storms and hurricanes, which cause significant damage to the environment, property, and infrastructure. The damage is caused by the high wind speeds, the volume and intensity of rainfall, which causes different types of flooding, and sea inundation from storm surges. Communities in the Bahamas were devastated by the 6-meter-plus storm surge that accompanied Hurricane Dorian. Many lives were lost as well as significant infrastructure damage. The scenario we'll be looking at is that of storm surge risk mapping. Scenario 1 looks at an approaching Category 5 hurricane passing through the Bahamas Islands, and Scenario 2 looks at a hurricane passing close to the islands of Anguilla and Dominica. Our methodology was to access the SurgeDat database and extract data from previous storm surges in the Caribbean over the last several decades. Based on these points, other accompanying land and sea variables were extracted and analyzed, from which a rules-based model was developed. A grid of sampling points across the countries of interest was generated, for which land and sea data was collected and the risk maps produced. This is made available via the Foresight platform, which can be accessed by a range of stakeholders, and they can bring this data into their own GIS platforms using OGC standards. The static risk maps are developed from variables which do not vary significantly with time, such as the bathymetry and elevation data. Here is the output of the static risk map analysis for the Bahamas. And here is the output for Dominica and Anguilla. We can see that Dominica, with its high elevation, is not at risk of storm surge, looking at just the static variables. The dynamic risk map was generated by analysis of the variables which change relatively quickly with time, such as wind speed, storm pressure, and tide. Here is a dynamic risk map for the Bahamas. This was integrated with the static using fuzzy overlay to produce a final storm surge risk map output. The weighted overlay technique was also tested. Here are the final storm surge risk maps for Anguilla and the northern part of Dominica. We will provide a persistent demonstrator for this pilot project through our Foresight Services platform under the Disaster Risk Management DRM section. We will provide direct links to each project for each country. Here is the final output of the Bahamas storm surge risk map displayed in the Foresight DRM platform. So this enables you to see the various output layers and to see the hurricane path in conjunction with the results, and then to analyze the risk levels. And then with this link, the OGC Features API can be used to export the data. The Foresight platform is built using Azure microservices with GeoServer in the backend. The data discovery and extraction processes were difficult and so took us longer than planned. We also observed that there was a mismatch between land and marine data from different sources. Storm surge modeling is an extremely complex task. Our model is a proof of concept, which we will continue to develop. Using OGC standards, data can be shared with others.